L'Hopital's rule is a rule for evaluating limits that applies whenever we have the indeterminate forms 0 over 0 or plus or minus infinity over plus or minus infinity. The rule says that we can evaluate the limit by taking the derivative of the top and the derivative of the bottom. So the first part of L'Hopital's rule says if we have a limit as x goes to a of f of x gives you 0, and the limit as x goes to a of g of x gives you 0, then the limit as x goes to a of f of x over g of x is going to be the same thing as the limit as x goes to a of f prime of x over g prime of x, provided that this second limit does exist. Similarly, if the limit as x goes to a of f of x is plus or minus infinity, the limit as x goes to a of g of x is plus or minus infinity, then the limit as x goes to a of the quotient, f of x over g of x, is the same as the limit as x goes to a of f prime of x over g prime of x, provided that the second limit exists. Note the caveat, provided the second limit exists. This means that if, by taking the derivative of the top and bottom, we get a limit we can't evaluate, then L'Hopital's rule doesn't help us at all. We need to turn to other techniques for finding the limit. However, if we do take the derivative of the top and the derivative of the bottom, we get a value for the limit. That value is the same as the value of the original limit. So let's use L'Hopital's rule to find the limits here. The first one, we have the limit as x goes to 0 of sine x over e to the x minus 1. So again, the first step is to plug in 0 for x. What do we get? We get sine of 0 on the top, and we get e to the 0 minus 1 on the bottom, which gives you 0 over 0. Whenever we have a 0 over 0, it means we are allowed to use L'Hopital's rule. L'Hopital's rule says we're going to try taking the derivative of the top, derivative of the bottom, seeing if we still get a limit. So we're going to use L'Hopital's rule. The derivative of the top is going to be cos x. The derivative of the bottom is going to be e to the x. Now let's try plugging in 0 for x. We get cosine 0 over e to the 0, which turns out to be 1 over 1, which is 1. Which means that this original limit equals 1. This limit goes to 1. So let's try this second example. We have a situation where we have the limit as x goes to infinity of ln x over x. Well, let's plug in infinity for x. Ln of infinity goes to infinity, the bottom goes to infinity. So we have an indeterminate form of the form infinity over infinity, which means we're allowed to use L'Hopital's rule. So we're going to use L'Hopital's rule, and what this says is we take the derivative of the top and the derivative of the bottom. The derivative of ln x is 1 over x, the derivative of the bottom is 1. Now we plug in infinity for x, we get 1 over infinity over 1, which is 0 over 1, which is 0. So that means that this original limit goes to 0.